Imagine this. An object unlike anything humanity has ever encountered suddenly appears in our skies, not from Earth, not from our solar system, but from the dark silence of interstellar space. Captured by the James Webb Space Telescope during a routine scan, the event began quietly. No alarms, no alerts. Just a strange, elongated object entering the field of view. But within minutes, everything changed. The telescope picked up erratic behavior. The object wasn't just passing through like the one in 2017. It was slowing down, adjusting its trajectory, and then, astonishingly, it stopped. Moments later, the live feed from JWST cut to black. The footage was scrubbed from NASA servers, and the object was quietly renamed Neo Umuamua. Internally, it was labeled classified. But fragments of the data slipped out, leaking through scientific backchannels and private observatories scattered across the globe. What those few captured before the feed was silenced was far more than a rock tumbling through space. It was pulsing, a perfectly timed sequence of prime numbers, aimed not at Earth's surface, but at the magnetic field surrounding the planet. A language of logic. A message not meant to be heard, but recognized. This wasn't communication. This was targeting. And we weren't ready. Across the southern hemisphere, telescopes in South Africa and Chile struggled to maintain a lock on the coordinates. Their systems began to drift inexplicably. Focus was lost. Lens systems degraded. No one could get a clear view. But other instruments, those less dependent on light, picked up something far more chilling. In Brazil and Ghana, atmospheric sensors recorded sudden pressure anomalies, the kind that suggest movement through the upper atmosphere, up and down, but no aircraft, no meteor, no weather phenomenon could account for the pattern. Thermal imaging indicated areas of rapid cooling and heating, as if the object were cloaking itself, regulating its own environment, active shielding. NASA's internal reports referred to it only as exhibiting non-ballistic motion, the term reserved for objects moving under intelligent control. In simple terms, it was flying itself. But it wasn't approaching us. It had found a place, directly above Earth's magnetic equator, and it remained there. Watching. Listening. Then something else happened. On April 7, a brief but global magnetic ripple was detected. Not from the Sun. Not from Earth. But from space. CERN's magnetometer array registered it across its entire network, a pulse 0.72 seconds long, filled with harmonic structures never recorded before. Just hours later, the impossible happened. Voyager 1, billions of miles away, at the edge of our solar system, transmitted a response. This wasn't just a signal. It was a structured, quantum-corrected waveform, layered in prime intervals. Voyager 1, launched in 1977, isn't capable of transmitting such a signal. Yet it did. Scientists now believe Voyager wasn't the source, only the relay. Something had activated it remotely. And that activation matched Neo Umuamua's burst down to the exact millisecond. It was as if a hidden network, scattered across our solar system, had suddenly come online. A network that's been dormant until now. Dr. Brian Cox, among the few willing to break silence, suggested this wasn't a visitor. It was a node. A sentry. Part of a larger system designed to monitor worlds like ours as we cross certain technological thresholds. Not to attack. Not to intervene. But to evaluate. To decide. The idea echoes what many now call the Great Filter, a theory suggesting that civilizations capable of reaching the stars are tested, watched, maybe even judged. What we thought was first contact, may be something else entirely. A test. A silent review of our readiness, or our danger. And while the world remains largely unaware, behind closed doors, a storm is brewing. Documents leaked from both NASA and ESA reveal that Neo Umuamua wasn't a surprise. Orbital disturbances near Saturn had been logged months earlier. Irregular heat signatures from the edge of the solar system had already been detected. But nothing was said. No warnings were issued. The data was buried, the reports shelved. One internal email from a senior ESA advisor reads, "The public cannot process what we're seeing, and so, the truth was withheld, until it could no longer be hidden." Now, the object hovers silently above us. Not moving. Not speaking. But active. Deliberate. The question isn't whether we're alone. The real question is, why did they wait until now to show themselves? And perhaps more importantly, what comes? The James Webb Space Telescope has captured something extraordinary. Light patterns that appeared to shine like artificial city lights from a point just 4 light-years away. This unexpected discovery has reignited global curiosity about the possibility of intelligent life beyond Earth. The telescope, while surveying Proxima Centauri b, the closest known exoplanet to our solar system, detected mysterious bursts of light coming from its surface. These weren't random flashes. They resembled structured illumination, similar in appearance to urban lighting, sparking a bold new question. Could this be evidence of an alien civilization? For decades, both scientists and the public have speculated about life beyond Earth. Theories, observations, and even science fiction have fueled our fascination. But when the James Webb Telescope delivered this data, the tone changed. This wasn't hopeful speculation, it was scientific intrigue backed by observable data. The lights on Proxima Centauri b have opened up serious discussion about what kind of civilization might exist out there, how it might be organized, and whether they, too, are looking back at us. The lights, although faint, seem far too precise and consistent to be natural geological phenomena or atmospheric events. NASA engineers were particularly struck by one question: how long have these lights been active? Have they been shining quietly for millennia, waiting for human technology to finally become advanced enough to notice them? Astronomer David Kipping from Columbia University explained that Proxima b is a particularly complex exoplanet. Unlike typical rocky planets that absorb light and emit infrared radiation predictably, Proxima b behaves strangely due to its intense relationship with its parent star, Proxima Centauri. Thanks to the telescope's unmatched ability to detect infrared wavelengths, researchers were able to observe unusual thermal behaviors from the planet's surface. This infrared sensitivity is what enabled the telescope to pick up the possible artificial lights, especially on the planet's night side, an area typically hidden in darkness. Detecting such faint glimmers is nearly impossible for older telescopes, but James Webb's precision offers a new window into what's happening across the galaxy. What makes this discovery even more compelling is Proxima b's dynamic environment. It experiences extreme day and night cycles, driven by the powerful radiation of its red dwarf star. During the day, the planet heats up under the harsh glare of its sun, but as it rotates, the night side cools drastically, especially if it lacks an atmosphere. If no atmospheric gases are present to balance the temperature, the difference between the planet's day and night could be vast. This would create a unique thermal signature, which James Webb is perfectly equipped to analyze. By studying these heat variations, astronomers can determine whether the planet has an atmosphere and what it's made of. If an atmosphere is confirmed, the next step is to analyze its chemical content. Scientists will search for specific markers, oxygen, water vapor, methane, that are considered key indicators of habitability. These compounds could suggest not just a potentially livable environment, but possibly even the presence of life. This type of analysis involves studying how the planet's atmosphere affects light passing through it, a technique the James Webb Telescope is exceptionally good at, especially for identifying substances like water vapor, carbon dioxide, and methane. Although it isn't optimized for detecting free oxygen directly, it can still identify related compounds such as ozone, which may also point to the presence of life. There's still a long way to go before definitive conclusions can be made. But for now, what the telescope has revealed brings us one step closer to answering a question humanity has asked for centuries: are we alone? And while Proxima b is just one of many exoplanets under investigation, it currently holds the spotlight. With each observation, each signal, each unexplained flicker of light, we're moving toward the most profound discovery of all time. And it may already be waiting for us, just 4 light-years away.